There we go. All right. Net Plus today, we are recording. Try to keep your background noise to a minimum if you can. All right. So last week we were talking about APIPA for some odd reason. I don't remember why. And we were doing I had a network up, so I guess I can bring it back up. But in the meantime, homework on APIPA, and we would revisit it today. And I know some of you have. So what do we know about APIPA? Let's just start with a group discussion. What can you tell me about it? Anyone, if you have an answer, shout it out. Let's spark up a conversation about APIPA.
Well, I guess I had to learn the hard way that it only works when everyone has an APIPA address. And if the DHCP is working and you bring up a APIPA address, you're going to be the only person talking to yourself. So thank you for that, Tristan.
Right, no worries. What else? So yeah, that's absolutely right. So if you do end up with an APIPA address, basically, that's kind of where we were leaving off, right? I think like the last question I asked was if the device that had an APIPA address could communicate with the other devices on the network, right? And the answer was no. And what he was basically saying is that it actually can work if there happens to be another device. Let's say that the first, whatever 5 or so devices are all on this network, and then something happens with the DHCP server for some reason, who knows? And then the next few devices that are added, they all end up with APIPA addresses. Well, the devices with the APIPA addresses, an APIPA address is actually, it's a range, right? It's its own subnet, right? And the way LANs work is any devices that happen to be on the same subnet can communicate with each other. So all the devices that have APIPA addresses will actually be able to communicate with each other, right? Because they're going to be in the same range. They're technically in the same LAN. But I have another question. Okay, so with that said, let's say that, all right, 1, 2, 3, 4, all right, let's say that all these devices over here are in this network here, right? So the 1.0 network, and let's say like these last 2 devices end up with APIPA addresses, all right? Maybe it did, let's see. Yeah, still has an APIPA address. So gotta figure out why the heck this one does 2. This one does 2. Oh, look, everything has APIPA addresses. Check this out. These have IP addresses, right? So something is definitely wrong, and we're going to troubleshoot and try to figure out what it is. Okay, so let's say that all these devices are on this network, and these 2 end up with APIPA addresses, all right? What can someone tell me about LANs and communication? If you're on separate LANs, right? So let's say, just for the sake of argument, even though these are all physically connected to the same switch, these devices over here have APIPA addresses, and these ones are all in this network, right? So, what can you guys tell me about LANs and communication? VLANs, more specifically. In other words, if I want to communicate with a different VLAN, right? Let's say this VLAN wants to communicate with another VLAN. Would this switch be enough?
If it was the stage 3, right? The layer 3 where actually had a router built into it, but with just, if let's say that switch is connected to other VLANs, it wouldn't be. I mean, so I guess I'm probably jumping ahead of the question there, I guess.
No, that's a great answer. That's a great answer. So yeah, if you had a layer 3 switch, then you would have to configure something that's called SVI, switch virtual interfaces. But that is a way that you can get devices on different VLANs to communicate. with a layer 3 switch, because a layer 3 switch is basically, it's just a switch with routing capabilities. It just has an extra function, kind of like a hybrid, all right? But without that, you would need at least, if you didn't have this, so let's assume which it is, this is the layer 2 switch, right? Would you be able to communicate with another VLAN if you only had a switch? Where's the chat box? Oh, there it is.
I wouldn't think so.
First team says no. Anyone else?
Well, it would have to be a managed switch, I would assume.
No. If you want to communicate with a device on another network, you have to have a router. At the very least, well, at the very least, you would need a layer 3 switch, which Wayne pointed out. But if you don't, then yeah, you have to have a router. There's no way that you're going to be able to communicate with a device on another network unless you have a router or something with routing capabilities. All right. Think of switches as local transportation, right? Think of it as transportation. So if you want to get around locally, right, you want to get to the grocery store or to the movies, to a friend's house, to the gym, whatever, right? You can call it Uber if you live in one of those areas. I don't know if it's everywhere yet, but I think most areas have Ubers now, right? You can call it Uber or a cab or something, and it'll drive you around, right? You want to get overseas, right? You're gonna need at least a boat, right? At least a boat or a ship or something, right? Or a plane. So I think of routers as airports, right? Because it connects cities, and that's basically what happens, right? If you're flying from LA to New York, right? That's what routers do. They connect other networks, right? So think of it as they connect cities and countries, right? And the switch just kind of gets you around whichever city you're in. Right, I think that's a pretty decent way to look at it. So if you want to get outside of your local area, you have to use a router or a layer 3 switch, which is basically we'll call a layer 3 switch like a ship, right? So you can get to Hawaii. You don't need a plane. You're not going to get there as fast, but you'll be able to get there, right? If you have a layer 3 switch, at the very least, right? So let's keep that in mind, all right? So the reason I asked that question now is what I want to ask is, let's assume here, right? We're still assuming because we do need to come in here and figure out what's wrong with this, which we will in a second. But so with these devices being on this network, right, and this one being on another one, and us having a router right here, right? Would I be able to communicate with one of these devices over here from one of these devices with their APIPA address? This is really important. That's why I'm bringing it up. Wayne says no.
Not if it's on the same. Not if it's not on the same subnet. So no.
Racing says no. All right, everyone says no. Awesome. You're absolutely correct. Right. One of the things is you definitely need to know about a APIPA, right? Outside of why you would see an APIPA address, but it's a linked local address, which means that it can only communicate on its own subnet, right? Even if you have a router, it's not a routable address. It's not routable. Okay. So with that said, what is the first sign you think that you would notice if a device on your network had an APIPA address? What would be the first symptom someone would think they would see?
The first symptom. What do you mean by that? Sorry.
Well, what's the symptom of having a APIPA address? What's the effect of having a APIPA address? What happens, right? What are your capabilities?
Can't reach anybody.
Let's say might not have a link line.
Exactly. Say that again?
Say you may not have a link light.
Okay.
No, you'll have a link light. What is the symptom? I don't think I understand what you're asking. I know your APIPA addresses begin with 169, obviously, so that's that's type of a symptom.
Well, it's
And
more
it,
of a sign.
I
Right?
think he's asking what an end user would notice. Is that what you're asking,
Exactly.
Tristan?
Yeah, exactly. Because most of the time we don't go around looking at IP addresses, right? We just try to access our devices.
oh, I see what you're saying. So you wouldn't. So I guess a symptom would be you wouldn't have a connectivity to the internet.
Exactly. There you go. Right? Maybe you're trying to communicate with another device, right? That's supposed to be on the network, and there's no communication. I'll give you a perfect example. About 2 weeks ago, something like that, right? I was troubleshooting my printer, and didn't want to work for some reason, right? So first thing that I do is my printer is it's a good distance away from my access point, right? So the first thing that I did was I just wanted to look at the signal strength, right? I wanted to make sure that I'm getting signal, right, from my router to my printer, right? Signal was good. It was about 75%, enough to print something, right? So the next thing that I did is I just kind of started scrolling through the IP, through the network connections, making sure that I am connected, right? And this may sound funny to you guys, but the first thing that I noticed, before I noticed the IP address was off, I noticed the subnet mask was off, right? Who can tell me all right, so let's start with the range, all right? We didn't get there yet. Can anyone here identify the range, the APIPA address range?
169.254.
Yeah. You gotta finish the last part too, though. So let me bring up a Word document. So yeah, if you see 169.254, more than likely you are somewhere in the APIPA range, right? And then it's 169.254.255.254. All right. So the main part that you want to make sure that you recognize is this. If you can recognize this, then you'll be good. You'll know that you're in the APIPA range, right? Everything else should fall in somewhere in between these, which is there's a wide range here. So, okay. By looking at this, right? We talk about subnetting a lot, so I want to see who pays attention, right? By looking at this, right? Who can tell me what the subnet mask would be for this address range? I give you a hint. Look for the parts that are similar.
.255.0.0.
Almost. Wait, did you say two 255s or just one?
Two 255s.
Yeah, there you go. You got it. So, yeah, 255.255. That's definitely not it. .0.0. Okay. So, and all you have to do to notice this is just look at the part of the address that is the same. It's the same here, and it's the same here too, right? And so, and then once it starts changing when you get to the third octet, right? And so, yeah, this is your classic Class B subnet. Okay, so as I'm scrolling through my printer, right, before I even noticed this, I noticed this, and I knew, I instantly knew, okay, something's up. And then I looked up and I saw this, right, and then I knew, okay, well, that's probably why my printer's not responding right now. It's on a different subnet, right? But my point is, right, I didn't go and look at the IP address until my printer wasn't working, right? So you got to think of when you think of signs and things, right? Do the same thing when you're on the exam. They're doing the same thing to you. It's just sometimes it's hard to visualize it unless you put yourself in a scenario. And it's easy for me to do this now because I just had this happen to me a couple of weeks ago, right? And it's easy for anyone else who's had this happen, but that's why I say hands-on is really important, because you have to go through experiences and stuff, so you have it in your memory bank. All right. So, yeah. Anyway, I thought it was kind of funny that I skipped past this. Right. I didn't realize I had a people address until I looked at the subnet map, because I was just skimming. Right. I was assuming that everything was good, but okay. So very important. Right. It was something that we talked about. Make sure you understand that an IP address is not routable. So one of the first signs that you're going to see is maybe you're on a device that has an IP address. You're going to try to go to the internet, and you're not going to make it. You're going to try to communicate with another device. Maybe you want to stream to your TV, or you want to stream music to somewhere or something, and it's not working, right? That's the first sign that you're going to have an IP address, and then obviously you're going to go in and look, because no connectivity, an IP address is just one symptom of no connectivity. It could be one of a whole bunch of different things, right? It's only one of the things that it could be. Yeah. Okay, so the range, make sure you know the range, all right? Secondly, the subnet mask, right? It's going to be your standard class C, right? 255s and 20, okay? Also, not routable. Okay, so you can connect with other devices that are on the same subnet, right? So if you happen to have another device, for instance, right, all these devices have IP addresses right now, right? So they should be able to communicate with each other, right? Shall we test it out? Let's see. I lost those options. How do I bring those back up? Here. Okay, so they just moved them. Okay. All right, so let's try to ping this line here. Successful, right? Try another one. For those of you that aren't familiar with Packet Tracer, it's a quick ping option right here. It's basically simulating just a ping, and it just lets you know if it's working or not, right? So successful. And then let's try to communicate with a device in a different subnet. It's not going to work, right? And it failed. Very important, especially when you guys are learning this stuff, practice it, verify, right? If you think something is the case, verify it, make sure that it is the case. If you believe that IP addresses can communicate with a device on another network, test your theory, right? Prove yourself right or wrong. This stuff is very important, right? So we're good here. As soon as we try to go outside the network, it doesn't work, right? Now we need to troubleshoot and figure out what the problem is. Before we start troubleshooting, does anyone have any other FYIs about APIPA that they want to throw in there? What is it a sign of, right? So we already spotted the symptoms, but if you end up with an APIPA address, what is the problem?
Well, if you've got a DHCP server, it's not getting an address from there. Right.
Basically, this means for some reason you're sending a dynamic request and you're not getting a response. So quick question. If I plug a device up to a network and I ask for a dynamic address and I get an APIPA address, does that mean that the DHCP server is down?
No. It could mean you're not even getting to the DHCP server.
Yeah, right. It could mean that it's maybe there's something blocking you from it, right? Because like all these addresses over here have APIPA addresses, right? But these ones don't. I'm using the same server for the entire network, right? So these addresses down here are good, I believe. Yeah, and then these ones down here, right? So the DHCP server has to be good, right? The problem has to be somewhere over here on this end of the network. See what else? All right, so basically no response from the DHCP server. The DHCP server failed to deliver an address, and so you ended up with an APIPA address. What else? Oh, I'll say LAN. Same thing, right? Same LAN, VLAN, right? So as long as it's an APIPA address, you can't communicate. This could also be misleading. If you have another device on your network that has an APIPA address and they're able to communicate, you may not even know that there's a problem. If you're just trying to stream, you know, like between devices or something like that. Okay. I think these are the main points, right? For this exam, be able to spot the range, right? Know why you would see an APIPA address, right? Someone tell me what I did to get my printer back up and running. What would you do? What would be probably the first thing you would do if you went to your printer and saw it had an APIPA address?
Reset it.
Reset?
Or reboot.
Yeah, power cycle.
Yeah, I just turned off my printer and I turned it on again.
Don't printers typically have a static address?
Well, if you assign
in the perfect world.
Yeah. I haven't assigned a static address for my printer, so nothing comes preset with a static address.
Right, you would have had to assign it.
Yeah, I would have had to assign it.
Yeah,
myself.
small networks and home networks probably not though.
Right. If you're in a company, if you're in like a big company, or it doesn't even have to be a big company, addresses to like servers, anything that, you know, a large amount of people are going to be accessing, those type of things you kind of want to have static addresses for, printers, servers, you know, things like that, things of that nature. So like sometimes people even, I mean, obviously you set static addresses for like my interfaces, right? On the router, these obviously have static addresses. I assign them myself. But yeah, for the most part, nothing's going to have a static address unless you statically assign it. Sometimes your access point will, when it comes your access point will, but and you can change it if you want, whatever you want it to be. Yeah, so I just turned off the printer, turned it back on, and then it received an address. So I don't know what happened. You know, who knows? At the time I was like switching between routers. One is it is a Aris, and the range for some reason they like their networks to be, so it's 192.168. So the common ones are either 192.168.0.0 or 1.0. Those are the common ones. Eric likes to use 254. So it's 192.168.254.0. Right, it's a whole different. So when you're switching between routers, sometimes you end up having to go, like any devices that you assign statically, you're gonna have to go and change them, right? Now you can actually, if you configure an access point with the same SSID and passwords as one that you were using before, to say that you're replacing one, and you assign the same bands. Obviously, it has to be the same band, right? Because not all devices will be able to connect to are AC capable, right? Some are just N capable. Some of them AC. Some of them both. But if you set up your Wi-Fi, as your SSID and your and your Wi-Fi and password and all that stuff, if you configure it the same, then you won't have to do it again, right? Your devices are just looking for a specific SSID, right? So it'll still give it an address, right? As long as everything is configured the same. But with your static addresses, you're going to have to go through and change those, assuming that you're on a different network. That makes sense. Okay. Anyway, I think we're good on that. Let's find out why we're getting the APIPA addresses here. Let's do it as a group. What's the first thing we want to look at?
Can you ping your gateway?
Okay. So ping the gateway, right? What's the address of this interface? 1.1, right? Actually, we shouldn't be able to ping it.
Right, because you can't.
Right. Well,
but there's no way to see if you're getting through the switch, right?
Right. No response. Shouldn't get a response. Still on a different network. Right. So all these devices are they're stuck in quarantine right now. Can't get out of their cities. This is what you would expect, right? So it's not much we can do from here, right? From these devices, because we already know that they're not going to be able to communicate with the router. So what should we try next?
What about setting a static IP just to see if you can get it to work?
Static IP? On one of these?
Yeah, we used to set a static IP just to test to see if we can get to the network that way.
Let's give it a try. So I'll come in here, I'll come to config, fast Ethernet. Someone has a lot of background, so I'm gonna disappear. Okay, cool. All right, so I'm gonna come in here, I'm gonna come to static, and I'm gonna pick an address that's on this subnet, right? 192.168.1.2. Right, we know 1.1 is used already.
Well, I don't know what your DHCP using.
What's that?
Because you want one that hasn't been assigned by the DHCP to somebody else.
Right, but remember the DHCP isn't assigning addresses in this subnet right now. The only device that has an IP address in this subnet is this interface right here.
Okay, I must have missed something somewhere because at one point I thought you just had 2 of the devices that had APIPAs and everything else was okay.
All of them do. Let me double check again. So yeah, that one's a APIPA.
Okay.
This one's a APIPA. This one's a APIPA too. And this wasn't the case last week. Wait, this one has an address. Okay, so something weird's going on. Good call, Kelly. Because I could have easily. Okay, so this one has 1.3. This is the only device that got dished out an APIPA address or an IP address. That's weird. Let's check the server real quick. Server, no IP address.
We need to renew the lease, maybe?
Don't know. Okay, so anyway, so let's try to ping from here. Real quick before we do it, is anyone, what do you guys say? Will it work or not?
We can hope.
Or not 1.2, 1.1.
I don't think it'll work.
You don't think it'll work? Anyone else? We're in the chat box. Wayne says it will. Okay, any more thoughts? Ryan says it should. All right, so let's see. Destination host unreachable.
So it's not, I'm trying to remember. So when destination host unreachable, that means that it doesn't, the destination host doesn't know about it, right?
Destination host unreachable, right? So
right. So
somehow
these two don't both know about each other.
That's weird. How did this happen? I wonder what I did. Okay. So from this point, where do we want to go from here? I want to take a look at my pool, at my DHCP pool, and see maybe I changed something if there's something wrong, right? And so you have to access to your DHCP server, which I'm pretty sure is this router right here. DHCP address conflict, server ping. Okay, so let's take a look. So here is my DHCP pools right there. So I have 3 of them. All right. These ones are working fine, it looks like. This one, this one, this one. Doesn't look like it's configured wrong. Let's see. So what is it? IP, DHCP, address conflict, pools information. Okay, so the one we're having problems with is the .1, right? So utilization mark, high, low, subnet size, total addresses, leased addresses, 0, excluded addresses, 0, pending event, none. Excluded total.
So are you sure that your address on your gateway is correct?
Yeah. The address on the gateway should be 1.1. If I hover over it, it says 1.1. Yeah. Subnet mask is good.
And the interface is up.
Yeah. If it's green, then the interface is up. So let me look at something else.
This is actually great because this is the kind of crap that you run into when you're actually trying to figure out a network or figuring out a network issue. You got to go step by step. So this is actually awesome.
I'm thinking it may be that ACL, because there's an ACL on that interface. When we were looking at it yesterday, I don't even remember putting it there. Maybe that's what it is. Because it's right here, right? You can see it right here. It's the ACL. So let's see what it's doing. It's like blocking the host, right? Yeah. So deny IP from 1.2 to 2.4. 4, right? This one was 1.2. I didn't even have a 1.2. All right, so let me try removing that and see if it works. Or actually, let me try this. I'm going to come back here, and actually I'm going to go to config, and I'm going to make another request to see what it does. I don't see how that ACL will block the ACL. It's giving me nothing. Oh, no wonder. Right. Yeah, nothing. Okay, so I'm going to try to remove it, see what it does. Yeah, so it still gives me the peak. All right, so let's see if that fixes the thing. I don't know. I don't see anything else. By the way, you guys, you don't need to know how to do this. Not for so.
So what
I
you're
was
saying
about to ask you where we. Go ahead, Kelly. Sorry.
I was going to say, so you're just wanting us to help you fix it.
Yeah, I was gonna say the same thing. Is this a test, Tristan? Do you want us to find this ourselves?
I'm trying to get group help, right? All right, so interface. What interface? Gigabyte 0/0. So GI 0/0. No IP access. IP
Could
access.
ACLs interfere with this?
You do it wrong, yeah.
Did you change any ACLs recently?
No, I don't even remember doing this one. I just see it on the interface, so I'm assuming that's a problem. But okay, access screw 100. All right, so I should have took it off the interface. So run. Yeah, so it's not on the interface anymore. And now the DHCP, look, addresses are being dished out now. It looks like, or no, it's showing conflicts. So, all right, let's see what. That one has an address. That one has an address. Look at that right there. This one has an address. That's what it was. It was the ACL. For some reason, the ACL was blocking the DHCP request, probably because it was set up wrong, maybe. I don't know. I had a permit statement, right, Kelly? Did you see one? And this one has an address too. So we're
I don't
back in the
remember.
game.
I just remember seeing one of those addresses up there and wondered if that was blocking something.
Yeah, hold on. So let me take another look at it. So we fixed it. It was an ACL. And it kind of, like, you got confirmation of that because as soon as I put that command in, you started seeing these pop up, right? And you saw these two conflicts. Why? Can someone tell me why you saw these two conflicts?
Those the ACL ones?
No, because before I disabled the ACL, I statically assigned this
Right.
address, right? So the DHCP said we tried to dish it out.
Right.
That's why you have this conflict. Right. And then there was another one that had 1.3. I think it was this one over here. So that's why you had these two conflicts. Well, hey, look, there you go. Everyone pat yourself on the back. It was the darn ACL. Okay, so let's take a look at it and see what I did wrong. Here it is here. This is list 100.
ACLs are a real cool idea if you know what you're doing.
Yeah, or you can lock yourself out if you don't, right? Case in point. All right, access list 100. So obviously this is an extended one. Your standard ones are going to be 0 through 99. All right, so you can either use a number or you can name it. It's up to you. But so this is actually an extended one, and so what I was trying to do was deny IP traffic from 1.2 to 2.4, and then I permitted IP traffic from any host to 192. All right, so I was really just trying to deny. I was trying to make sure that one device over here couldn't reach. I think it was probably the server over here. I think I remember now. It's like the server.
I think I remember that.
Okay, yeah. So would that affect the DHCP server? It's weird. I have my deny here and I have my permit any. So I don't know. That's weird. But okay, yeah. So we fixed it. Awesome activity, man. That was good troubleshooting right there. So let's recap real quick. So the first thing that we did was we identified where the problem was, right? Obviously, it was over here somewhere, and it wasn't the DHCP server itself because all these devices over here and these devices down here all had addresses within their subnet range, right? The only ones that were getting the APIPA addresses were this one. So that kind of gives you an indication, especially when you have multiple, routers in your network. It sometimes helps when the problem is kind of localized to a single area because it kind of tells you where to key in at, right? So I didn't come troubleshooting over here or over here or over here, right? I kind of started here, right? Then the next thing we did was we just kind of started doing stuff, right? So we did a ping to see if it would work, right? Obviously, we want to do a trace route in this scenario because we understand that the problem is local, right? So if you get a question on the exam, right, and you know that the problem is local, it's somewhere inside your network, right? You're not having problems outside the network, it's just inside the network. In that instance, that eliminates trace route, right? So you guys have to remember that. You're not going to do trace route looking for problems when you know looking for problems outside the network when you know the problems are kind of inside the VLAN, right? So we just went over here and I just looked at a few configurations to see what the problem could be. The only thing that stood out to me was I saw the ACL was on the interface that we were looking at. So this would be the interface. Don't forget there's other interfaces on this router. So we're not really troubleshooting over here yet, right? We're kind of focusing over here. So you have to make sure that you're on the right interface. So this is really the only one that I was looking at. And the only thing that really stood out to me was I saw an ACL there, even though it didn't look like it would stop DHCP traffic. For some reason it was, right? So you just remove it, and then see if that does the trick, and it did, right? It's the same thing for any other troubleshooting process. You kind of start with the simple stuff like we did, started doing a couple pings, right? I changed an IP address over here to see if it would work or not. Right, and then we kind of moved over here and started looking at some things over here, okay? For the most part, just remember the concept, right? Like I said, you don't need to be over here. You don't need to be able to configure ACLs and install them and all that stuff, right? And to place them. You just need to understand the concept of ACL, what it's there for, what can happen if you don't do it right. We just had a prime example, right? Somewhere I messed up. I still don't even know what I did wrong, but it's a learning experience, right?
We could troubleshoot that next week.
Yeah, right. Find out what was wrong with the ACL and figure out how to do it right. But yeah, and what else? Oh yeah, so main thing, just remember the concepts, okay? A APIPA address, right? Why you're gonna see it, how to notice it, and then how to troubleshoot it, right? So with my APIPA incident with the printer, it was a little less, I had to do a lot less than I did this time, right? It was just kind of a shut it off, turn it back on. I was pretty sure that would solve it because if I was having problems with my DHCP server, it wouldn't just be my printer, right? So that solved the problem. In this instance, we had to go in and do some searching and some looking and stuff. And this is stuff that, I mean, like I said, you don't need to know how to do it right now, but it's a good idea to kind of get used to this stuff, especially if you're going to be moving forward to like Cisco. Being able to go through and look at output and determine, you know, if the changes that you've made are right or wrong, right? That type of stuff. Being able to verify, make changes, and go in and make sure that everything is happening right. So the last test, obviously, I mean, this should work, but we want to make sure that we can, in fact, get over to another VLAN now, right? We couldn't do that before. That was the problem. And so the last thing is to double check and make sure that now you can, right? So let's do a quick ping here. Let's try to ping the server and see if it works. And it works, right? So that's why I love packet tracers. This is such a good tool to be able to go through and troubleshoot, because it's like real life type stuff. It failed the first time, I guess, because it didn't know where to send it. I don't know. That's weird. Then it works the second time.
No, that happens sometimes when it has to, when, like the first time you ping, you know, when you first set up a network, sometimes the first trip doesn't make it because it's got to get added to the
to the cam table, right?
Thank you. Yes, my brain
Yeah.
checked out.
So basically what she's saying is like this failed right here because I just started this network up, and then so I guess the addresses weren't in the cam table. So when I sent the request over here, it didn't know where to send it at first, right? It had to send out an ARP, and it happens real quickly. You can see how quick it happens, right? It comes over here and it failed the first time. It basically sent out the ARP to figure out, okay, who is connected to me and what are your MAC addresses, right? And then once it figures that out, the next time I sent it, it went through. And it happens really fast.
You can see it with a ping when you first set up a network. The first one sometimes will time out, and then the following ones will connect.
Yeah, you're absolutely right. Let's see, all right, this is 2.3, so let me try 2.3. See if it does it this time. It went through this time. Let's try another one. Oh, actually, you're right. It knows it now because it sent the ARP to all of them. Okay, it kind of only works when you just bring it up. If for some reason the MAC addresses aren't in the cam table.
It might work if you were to clear your cam table. I can't remember how to do that, but
yeah, me neither. I have to Google it.
yeah, it's been a while.
Okay. All right, so we got about 10 minutes left. Any questions on what we covered today? This was good stuff. I always like when we do live troubleshooting because there's no substitute for it. You can listen to lectures all day, but there's no substitute for having a problem and going in and fixing it. Because now it's in your muscle memories, in your memory bank. You know, it's experience. It's not just something that you heard.
And I think the discussion helps too.
Yeah, definitely. Definitely.
I liked your analogy. I have another one because I live on an island. Your little network over there reminds me of the island. We have, from the north end, we have one way off the island. And if that way goes down, we're isolated. So that's like that router. That's our one way off.
Oh, wow.
Well, Kelly, what about your helicopter? Come on, we know you got a chopper.
Well, okay, and there's boat, you know, people have boats, and there's a ferry, but I have to drive 45 minutes south to catch the ferry, and then it puts me way out of where I want to be. So, but it just reminded me of that because that bridge is so critical to us that even the water supply actually comes across that bridge.
Wow.
Yeah. But that helps with the analogy because I go, oh, well, so if the bridge goes down, I can't get to anybody outside of the island. And it's, you know, we've had it blocked in the past with windstorms, take trees down and stuff. I
Right,
think
the
3 days
bridges.
is the longest we've been cut off.
Wow. So the bridge is literally your default gateway.
It really is, yes. Yeah. Especially the ferries, most of the time the ferries run, but sometimes if the tide's really low or if the waves are really bad, they have to shut down the ferries too.
Right, got you. Okay. Wayne has a question about BGP. I don't remember it being. You know what? I think it is on. There is BGP somewhere on the objectives.
Yeah, it's not. I
Forget.
don't think it's real deep though. I think it's just kind of knowing what it is.
That was my
Yeah.
question. Reading about it, I thought, wow, this is sort of, we haven't really, I'm sure we touched upon it, but we didn't go in depth into it. So I thought, okay, is this something I need to be concerned more about? Because I'm not getting this concept. But what do I need to do? And you basically answered that. Thank you.
Yeah, I think it's most often used with internet service providers.
That's what I couldn't get when I was reading through it. It wasn't really talking. I thought you did with groups and organizations. I thought that's what I was wondering. It was something upstream for your internet providers. Yes, ma'am, you're right, and you said that. And that's what I couldn't get. Okay, why? What's this concept now? And I just wasn't grasping it.
Right. I know they bring it up on the exam, but the main ones to just know the characteristics of. I think they just kind of touch on border gateway protocol. It's not something that you don't need to go into it and where are the objectives at? The main ones you want to know is RIP version 2, EIGRP, OSPF. Know which ones are link state, which ones are distance vector. Know the characteristics of link state versus distance vector, which we talked about that a few times as well. But the main thing is distance vector is hop count. It uses hop count to make its routing decision. Link state uses metrics, so it uses like speed and efficiency. Where are my? I can never find anything in this computer. For those of you that are watching me, don't do what I do, because I go looking for stuff. You should let the computer find the stuff that you're looking for. As long as you know what you're looking for, the name of what you're looking for, if you put it down here, the computer will find it. Open an A+ note.
Kristen, he also asked about AS or ASN, and I can't remember what those are.
Okay. It's not A+. Come back. Objectives. So let me see what's on here under BGP. I know where it's at though. It's under.
Yeah, the ASN says primarily Cisco stuff, but it was saying the AS, the autonomous system, that was dealing more just networks in general, how they were organized and controlling. That's just sort of threw me. I thought, okay, I don't really remember even talking about this in our lessons. It's barely talked about here, so apparently it's not super important, but I guess I'm sort of anal retentive. I like to know how things work and why they work. So when I see something, it's like, okay, so what does this mean? How does this apply? What does this mean to my future understanding of things?
Right. I don't think that you're gonna have to worry about that for this exam. BGP, I guess the main thing that you need to classify it as a hybrid, because you can use different routing protocols within BGP. So if you have multiple, let's say that you have multiple stations, right? LearnKey does. It has like 3 main offices, right? So let's say if in one office they want to use RIP version 2, or I don't even want to say that. Let's say that they want to use OSPF. You're not pigeonholed to OSPF, right? If you're using Border Gateway Protocol, it's kind of almost like LAN controllers, right? Like LAN controllers, pretty much just like a central location to manage all the access points in your network, right? When you have multiple ones. Kind of like the same thing, right? With BGP, it's kind of like a central management for all of the routing protocols in your entire network. but the main thing to remember is that you can use different routing protocols, right?
So
You're not
does it,
stuck using one.
so is it like a combination of distance vector and link state?
Well, it depends. You can use whatever you want. So let's say in one office, in the St. George office, that they want to use RIP version 2 for some reason, right? It's a small office, so okay. But in Salt Lake City, it's a bigger, right? There's more people, and it's a bigger office. So it says they want to use EIGRP there, right? They can do that, right? Whereas if you're in one, let's say you're in one network, right? If I try to connect, let's come back here real quick. Right here, if I decide that I'm going to use OSPF here, I have to use it here and I have to use it here, right? I can't use OSPF over here and use EIGRP over here, right? They're not going to neighbor up, right? So what BGP does is it kind of gives you a broader scope. So let me make this smaller. So let's say that this is one network over here, and I had another one over here. And I had another one over here. So let's say this is our St. George office, and this is our Salt Lake City office, this is our Cedar City office, right? And they could just be mirrors, really, of the same thing. All I'm really saying is that if I'm using EIGRP over here, if I'm using BGP, I can mix it up, right? It's still an essential management for all of the networks, but you can use whatever you want over here, and you can use whatever you want over here, and you can use whatever you want over here. You can't mix and match this within here, right? But you can mix and match between locations. So I don't, if you want to use something else over here, that's fine. It can still be managed under the border gateway protocol.
That makes sense. I'll read you what it said, and now you explain it. I got it now. But it says that the BGP is the glue that glues the internet together. It holds the internet together. Each autonomous system can use whatever it wants to use, like the ASPF. The internet has still that protocol to communicate between each thing. But the border gateway protocol is the glue. One more time. BGP is the glue of the internet that connects all the autonomous systems together.
Right.
And that's what threw me. But you explained it very well now, so that makes sense. I'm grasping now what they're getting at.
Yeah, just think of it as like a central management protocol, right? That's why I use the LAN controller as an example, right? Because when you have multiple access points, I mean, obviously you can connect to all of them using Secure Shell, right, or even Telnet if you want to, without having to physically go to each one of them. But when your AS, right, your autonomous system is spread geographically, like LearnKey is, right? Salt Lake City is not that close to St. George, right? It's still one management. So when you're divided like that, then you can use BGP as like a central management for your entire network, right? Even though there's sections of it, you have one office here, you have another one over here, you have another one over here, but you can still manage it from a central location. That's kind of what BGP is for. It just kind of manages your entire network. So. Okay. Good session today. I think we got a lot of good topics covered, and we did some good troubleshooting. So I'm going to try to think of another exercise that we can do next week. I want to kind of keep this going. I think it's
solve that
better
ACL issue.
Yeah. Figure out. Oh yeah, you're right. Figure out how we can do it right maybe next week. So ACLs are important. You don't need to know how to configure them for Net Plus, but you do need to be able to recognize the signs of them, and you need to. The main thing you want to know about the ACLs is that there's an implicit deny at the end of each of them. This is something that they can test you on Net Plus. I think I remember seeing that. So just remember that if you don't remember to permit the devices that you want to permit, you're going to lock everything out. Similar to what we did, right, with the DHCP. Something about that ACL just kind of blocked me from being able to reach the DHCP server for some reason. So
I can't remember. Do you have to be able to interpret an ACL, like what it's going to block or what it's going to allow? Net Plus?
Not on Net Plus. On Cisco,
okay.
Yeah.
Must have been Cisco.
Yeah. Not on NetPlus. You just really need to know the purpose of an ACL for NetPlus. On Cisco, you need to know what it's going to do, if it's correct or not. So, okay, let me get the name. I'm sorry, guys. I forgot to do that.